It really is just a matter. I mean, we talk about the trial and error. We talk about identifying factors and things of that nature. But there are little tricks of the trade along the way. Some other methods that could be used. I tend to stay away from, when it comes to factoring, introducing too many alternate methods too early on, just because, I mean, that just confuses the living daylights out of people. But in terms of the method that we are using, there are little tricks. And so when we look at that C value of 2, we notice that that's a positive number, all right? So when you have a positive factor, I'm sorry, a positive value, its factors have to have the same sign, all right? So when I'm setting up my framework here, my two binomials, I know that these two signs have to be the same, either minus minus or plus plus, all right? Now, since that middle sign is negative, those two factors have to contain negative signs, all right? Because there's no way we're going to introduce, let's say we put plus plus here. If I put plus plus here, how am I going to come up with a negative sum, right? So there's no way that that would happen. So the only way it could happen is if the two signs were negative. All right, so it allows you to kind of take one ingredient out of the conversation. All right, so if your C value is positive, your two signs are the same, but specifically whatever the middle sign is. All right, that's a lot to write down, so I tend not to write it down. It's something you think about. All right, so if the C value is positive, we know the signs are going to be the same. It's just a question of what those signs are going to be, positive or negative. If you look at your trinomial and it's entirely positive, your two factors should be entirely positive. But if it's not, then you know that it has to be two negatives. All right. Then we're looking for factors of 9u squared. All right. So if I'm looking for 9 factors of 9, we're looking at either 3 and 3 or 1 and 9. For the 2, possibilities are really 2 and 1, 1 and 2. All right, because 2 is a prime number, I'm not worried about any other values there. All right, so really I'm kind of looking at this from the reverse perspective. Because 2 is a prime number, I can actually place my 1 and 2 and then worry about what the leading terms have to be. All right, so I know I have to have a couple of u's in there. All right, so I pop in a u here, I pop in a u here. I think that's obvious by now, hopefully. So it's a question of, all right, is it going to be 3 and 3 or 1 and 9? I always try I mentioned this before, I try the repeated value first, because that's the one where I wouldn't have to worry about swapping the order, all right? So I make my arc diagram, and then I put my suspected coefficients in there, 3 and 3. So I'm looking at negative 3u, negative 6u, and that would give me the negative 9u that I'm looking for, all right? So it wasn't really a matter of, I mean, it may seem like I just got lucky and I got it all, I got it on the first crack. That's great, all right? But it was part of the strategy, all right? Now, it is entirely possible that the 3 and the 3 wouldn't have worked out, and if that's the case, then what? You know, like then I got to go to the 1 and 9, all right? And there's nothing wrong with that, all right? So when we look at number 15, we know our framework is got to have a t, well, that's because that's what the variable is, with minus signs, all right? And that's because it's a similar situation where the c value is positive, so we know the signs have to be the same, with the middle term being negative, so they're the same and also specifically negative, all right? So the 4 is my leading coefficient, so I need factors of 4, so that's 1 and 4, 2 and 2. So again, another one of those repeated situations. We just move a little, give a little bit more room there. The 7 again is a prime number, so 1 and 7. So I'd place my 1 and my 7. And just to be clear, it's not like people were getting these problems wrong. It's more like they were getting them right, just not in the most efficient way possible. All right, so it's just my way of getting across some strategy. All right, so I got my 1 and my 7 placed in there. I'll try the 2 and 2 because, again, that's my repeated value. All right, so I'm looking at negative 14 and a negative 2. That's not going to get me to a negative 11. So now I know I'm done with the 2 and 2. There's no other possible way I could put a 2 and 2 in there so that it would work. So these are done. Oops, I still need that parentheses or parenthesis. So now I would try the 4 and the 1. But again, the strategy part of it, the placement of the 1 and the placement of the 4. Since you know that you need an outer and inner product, I would never put the 4 here. All right, I would never do that. I wouldn't even consider it. All right, because that's going to give me an outer product of negative 28, which is way too far away from the negative 11. All right, so I know now that if it's going to work, it would have to be the 1 here and the 4 there. Negative 28t, I'm sorry, negative 28, geez, that was the thing I was trying to avoid. Negative 7t, negative 4t. That gets me to the negative 11t. Which happens to be what we're looking for. All right. So it's little things like that, but you know what happens is people just try to cut corners, get the answer as quickly as possible, but you lose the skill, the number sense that goes along with it. All right, and it doesn't serve you very well down the line. All right, so like things like the grouping technique and the AC methods, they're fine. They're techniques. They'll get you the answer, but since they're algorithmic, that you're really not developing any skill other than applying that one particular procedure. All right, so when it comes time down the line to be able to factor quickly, you're always going to have to follow that 7-step process to get your answer. And it's always going to take you the same amount of time. If you try it this way, you know, maybe you try it like you like some other method, that's fine. You try it using my method and then default back to your other method, but at least give my method a shot, because this way will allow you to do it in your head sooner rather than later. The more you practice it, the easier it is to do in your head. All right. So that's just a little soapboxing there for you. All right. Anyway, so what you're going to do first, so we don't want to do this out of order because there are some deadlines that you want to be mindful of. So page 35 comes first. Same rules as before. Honest effort on every problem. Take a picture of your work. I need the work too, folks. It can't just be the answer to the riddle or whatever. Like, that's great. It's nice to know what the riddle was, but I mean, I could just tell you that, / you could look it up on the answer key. Like, that's not the point. The point is for me to see where you're at with this content, which means I need to see your work. All right. So if you submitted the assignment yesterday and you didn't get a grade for it, check the comments, because most likely it was because of you didn't submit any work. All right. So I need the work. So solve each problem, attempt them the best you can, take a picture of your work and submit that, and then you can move on to the IXL. So number 6, again, anytime you're looking to factor a trinomial, specifically a trinomial, we're looking for values that'll multiply to the first term and values that'll multiply to the last term. But something to consider, and it's pretty important because this is kind of speaking to efficiency rather than just kind of like going through the steps and getting it right. I mean, you can go through the steps and get the answer, but if it takes you 5 minutes to do each problem, then, you know, that's going to add up. You know, if you can get it down, you know, maybe to like 1 minute, that'd be beautiful. All right, somewhere in between, that would be, you know, we'll settle for that. But before too long, you'll find yourself being able to just factor without really taking much time at all, like 30 seconds. It's kind of hard to believe that would be the case, but you get so experienced with it, you notice certain trends that recur over and over again that you're like, oh, okay, well, I know how to do this one, so boom, boom. All right, oh, this one takes a little longer, so let me take my time with this one, you know? And so you're only really taking the time with the more challenging ones. The easier ones, they come much quicker. The the question of efficiency comes into play when you make observations while you're doing the work. All right. So yeah, we do the arc diagrams. Those are helpful. All right, but eventually the arc diagram is going to be more of a kind of a mental sort of thing, like where you're like, okay, what are those two giving me? Those two, put them together. Oh, okay, that's what it's going to be. You know, so you won't physically be doing the diagram anymore. All right, if you get where I hope that you will get. All right, so I know in this case I have to get to a C value of 1. All right, I can list out the factors of 1, but that's, you know, it's obvious. It's 1 and 1. All right, but it could also be -1, -1. So it's the question of which one is the correct one. So the thing is, when you have a positive C value, we know that the two binomials have to have a negative sign or a positive sign in both of them. All right, so because the only way you get to a positive product is if you multiply two negative numbers or two positive numbers. All right. So if you look at number 7, for example, and this is what I've been saying all along, if the trinomial is entirely positive, then why would I put a negative inside my parentheses? It wouldn't make sense, right? But this one is not entirely positive. So if I know that I have to multiply to a positive value, my two signs have to be the same, the middle sign would have to dictate what that value is. Hey, Mark.
I'm sorry to bother you.
No, not at all.
Mr. Green wants to see how you look for this kid.
Oh yeah, okay, yeah, it's all in the unit packet. He actually has the packet with
He
him.
has the packet? Okay.
Yes, so.
I just saw your pen.
Oh, hold on.
Thank you.
This pen.
He has the packet.
Yeah,
Okay.
so we're doing page 35 in the unit packet.
And he should know that, right?
He should, yeah.
Page 35 in the unit packet.
Yep.
Mr. Kent. Okay. Thank you so much.
Yeah, thank you. So if we know the two signs have to be the same, and that middle sign here, so this bad boy right here, dictates what that sign is, then I now know that these two signs have to be negative. All right? So it's a little visual cue or clue or whatever the right word is that tells you what the sign distribution has to be. So now actually looking at numbers 3, 4, 8, 15, 3, 4, 8, and 15, in addition to the one that we're talking about now, every one of those questions would all have to have minus, minus. All right? We know that the cases that have no minuses, so the like numbers 1 and 2, those are going to be plus and plus. So then it becomes only really a question of what do we do when there's a negative C value. All right, we know the signs have to be different. It's just a question of which one goes where. So I'll get to that in a minute. But that'll be when we do number 16. But now I know that these two values have to be 1 and 1, but specifically negatives. All right, I have my variable u. So now in this problem, I've taken really almost all of the guesswork out of it by just saying, all right, how do I get to an 8? Well, an 8, I can get to that by a 1 and an 8, or a 2 and a 4. So it's really just a question of placement. All right, so I'll try the 1 and the 8, and I'll try the 1 and the 8, and if that doesn't work, I'll try the 2 and the 4. So let me put the 1 here, the 8 here. So negative 8u, negative 1u, got it on the first try. All right, but that's because I took care of everything else along the way. All right, negative 8u, negative 1u add together to give you a negative 9u. All right, but the observations that you make by using the technique eventually help you to not have to use any technique. It's just you'll look at it and say, all right, well, it has to be this arrangement. Otherwise, you know, it could never possibly work out. All right. So the same strategy would apply for numbers 3, 4, 8, and 15. But then we get to number 16, where we talk about a negative C value. All right, a negative C value tells me that the two signs have to be different. All right, two negatives will multiply to a positive, two positives will multiply to a positive. Any other combination of signs will multiply to a negative. So I need to get to a -1. All right, so one of them's got to be a positive one and the other's got to be a -1. Which one? I don't know. Frankly, don't really care. We'll let it all work itself out. All right, so I know I have to have a t in there. Do my arc diagram. So that's not much of an arc. So now I just want to think, I'll live with that. Think about the factors of 6. 1 and 6, 2 and 3. All right, so I've pared this down so that the only guesswork is what is the coefficient of t. All right, now this gets more challenging if my c value is something other than a 1 or a -1, because then we have potentially many more possibilities. But you'll notice in every one of these cases, the c, well, with the exception of one problem, the c value is either a 1, some kind of 1, or it's a prime number. So there isn't really much to do when it comes to the c value. This whole assignment was really more about how you handle the a value. All right, but again, I'll just put in something and hope it works out, and if it doesn't, then I'll try something else. So the first thing I wrote down was 1, 6, so let me put in a 1, 6. Outer product -1t, inner product 6t. 6t plus -1t gives you a 5t. All right, now that I'll call that luck. Sometimes, there's the old phrase, chance favors the prepared mind. It's one of those things where it's like, sometimes your level of experience kind of drives your luck factor, where it's like, well, why did you put the 1 there and the 6 there? Did you have some sort of intuition that led you there? Yeah, maybe, probably. All right, but I wasn't really thinking about that. I was just saying, what's the first thing I saw? 1 and 6. I could have easily wrote down 2 and 3 first. All right, but if that didn't work with my arc diagram, then I would have tried something else. All right, so hopefully you got something out of this. 4 and number 14 are both obviously trinomials, but they each have something a little different going on. In the case of number 4, the c value is positive. If the c value is positive, the signs in your binomials, or signs that comprise the binomials, have to be the same. All right, so when we set up our set of factors, you can start making some assumptions just from experience, where you'd say, all right, so if I know it's got to multiply to a +2, the factors are going to be 2 and 1, and that's not really the important piece just yet. It's really about the signs. So if this is telling us that the signs are going to be the same, then it's just a matter of deciding, well, which one is it going to be? Is it going to be both positive or is it going to be both negative? All right? Whatever the b value is will dictate the sign that you use in the parentheses. All right? So if we know they're going to be the same signs and the b value is negative, then these two signs each have to be negative. All right? So I know I'm going to have a 2 and a 1 in there. I don't know which order, but I'm just going to make an assumption. I'll put the 2 first, then the 1. But you can go the other way around also. I know I'm going to have an x in each binomial. It's just a matter of what my coefficient's going to be. All right? So my a value has a coefficient of 7, or my a value is a 7. So those are factors of 1 and 7, possibly -1, -7. Could be the other way around, but the absolute values that we're interested in here are 1 and 7. 7 is a prime number, so that's the nicest possible situation. All right, if you come across situations, I mean, it's not that you need to actually identify them and say, oh wow, look, I have prime numbers here. What a great circumstance. It's more like just understanding that when there are prime numbers, it's going to be a whole lot easier than when they're not prime. All right, because if a number is prime, it's only divisible by 1 in itself. So how am I going to get to a 7 with a 1 and a 7? How am I going to get to a 2 with a 1 and a 2? Just a matter of placing them in the appropriate order. All right, so 1 and 7, so I'll try putting the 1 here and the 7 there. If that doesn't work, then I'll just switch them around. If that doesn't work, then it's not factorable because I will have tried every possible combination that makes sense. All right, so create my little arc diagram. I got a negative 14x and a negative 1x. That doesn't get the job done because I'm looking for a negative 9. All right, those two would have to add to a negative 9. So no good there. So then I would swap the 7 with the 1. All right, so my inner product would be negative 2x. My outer product is negative 7x. That does give me the negative 9 if I add them together. All right, so knowing that my signs both had to be negative took a lot of the guesswork out of it. Because I had some prime numbers, so it's just a matter of, okay, I'm gonna place the 2 and the 1. It's just a matter of where my 7 and my 1 were gonna go. All right, and if it didn't work one way, it would have to work the other way. Otherwise, it would not be factorable. All right. When it comes to questions on practice test or actual unit test, just be mindful that sometimes a problem may not be factorable. All right. If that happens, though, I'll say in the directions, factor if possible. All right. So that'll be your indicator. Or if it's a multiple choice question, you'll see one of the choices being prime or not factorable or none of these or something like that. Right, but there'll usually be some kind of clue in the setup that'll kind of let you know that you're looking for something that wouldn't be factorable. All right. Now, number 14, the C value is negative here. All right. If the C value is negative, that's telling me that the signs have to be different. I'm just going to use a not equal symbol there. All right. So the signs would have to be different. So I'm looking for a product of binomials where one is going to be positive and the other is going to be negative. All right. Now my factors for my A value, 3, 1 and 3. For the 5, 1 and 5. It's just a question of placement. All right. I know there's going to be T's in there. So that's something. So now it's just a adventure in guessing and checking. All right, so I'll try the arrangement that you see here: 1 and 3, followed by 1 and 5, and see if that checks out. All right, my outer product would be negative 5t. My inner product would be 3t. Add them together, I do not get a 14t. So this is not the correct arrangement. All right, so then what I would do here is swap my constants and see if that gets the job done. All right, so outer product negative 1t, inner product 15t. That does get the job done. 15t plus negative 1t or 15t minus 1t is 14t. All right, so I have my two factors. Now, if that didn't work, then you'd start questioning whether the situation was factorable, right? Because again, the leading coefficient and the C value are both prime. So there's only so many ways that this can go. Right? If I had something like my leading coefficient of like 128, you get a bunch of different factors of 128, makes it much more complicated. But when they're prime, there's really only four different ways you can kind of arrange everything. All right, so once you go through those possibilities, if it doesn't work out and you're confident that you did the algebra right, then you would say it's not factorable. All right.